Welcome everyone to our Week 2 recap video. I've gone over the participation survey results, and I've selected some problems here that I think would be useful for us to go over. Just as a reminder, our exam is next Wednesday, so we only have about a week or so, assuming that you watch this today, Wednesday, before our exam. So I guess in honor of that, I've chosen questions that I think would all make fine exam questions. They're kind of in the medium. I guess admittedly, I made this one a little bit more difficult on myself, so maybe this is medium hard or so level difficulty. Again, as always, feel free to skip around this video and only watch the parts that you find that you need help with. For instance, as I was looking at the participation results, I saw that still people were interested in going over more trig functions. So you can see actually I've combined trig functions in all of my derivative questions here. So we'll get some good practice on that. The trig was the 2.4. Also wanted to talk about when to use kind of each one of these rules, right? So for instance, the product rule and the quotient rule and the chain rule and things like this. There were some people who definitely wanted to talk about that. So I'll kind of also look at these things at kind of more of a macro or global level and tell you, kind of when you should be using each one of these rules. But before we get to that, let's start it off with example number 1. There was still, right, these ones end up being quite algebraically challenging. And so I wanted to go over one more of these. There was definitely some requests for these tangent line ones where you had to use the limit definition of the derivative. So that's where we're going to go ahead and start. So, all right, the big thing here, the limit definition of the derivative, right? We're getting to the point, especially with our knowledge in 2.3, 2.4, and 2.5, right, where we know a lot of rules for how to take the derivatives quite quickly. But it turns out, right, no matter how many rules you make up, there's always going to be functions out there that don't fit into those rules. And so it's important to still know kind of what is the derivative, where it comes from, and that's why it's an important skill to kind of, still remember the limit definition of the derivative and being able to utilize this. So you can't completely forget this, even though we have a lot of rules. And in fact, on many of the previous exams, and even on the final exam, I've seen questions that say use the limit definition of the derivative in order to calculate out some derivative. If you use rules or anything like this, you don't receive any credit. So it is very important, not only kind of, knowing this moving forward, but also for our assessments, our exams and whatnot, to remember the limit definition of the derivative. So with that, okay, let's say, well, what is this limit definition of the derivative? Luckily, this is given to us on our formula sheet. So I'm going to go ahead and bring up our course website here under useful links and midterm formula sheet. If we go to this link here, I'll show you exactly where it is. Again, I highly recommend that you print this formula sheet out and are carrying it around with you, and you know exactly what's on here and what's not on here. Because not everything's gonna, be on here maybe that you want. So it's important that you still memorize some things, but certainly if it's on here, you don't need to memorize it. So here it is, this very first one for derivatives. So it says f prime of x is equal to, and there's the limit. The limit as h goes to 0 of this difference quotient, this f of x plus h minus f of x all over h. So, if it comes to the exam time, nerves are getting to you and stuff like this, right? Remember that this is on our formula sheet, and so you don't have to guess and perhaps get it wrong. So, okay. So that's where we're going to go ahead and start here. I'm going to start writing down the derivative for our function is equal to the limit as h goes to 0 of this f of x plus h minus f of x all over h. Now let's go ahead and start plugging in our specific information, right? We know what our function looks like. It's the square root function. So f of x plus h. So everywhere I see an x, I'm going to plug in my x plus h. So I have this 3 plus the square root of 2, but now instead of x, I'm plugging in x plus h. And then there's also this plus 5. That's all under my square root. So that's my f of x plus h. And then we have to subtract away f. So 3 plus the square root of 2x plus 5. So there is my f of x right there. And you have to be careful because as I've written it, in fact, let me go ahead and put my division by h. I've actually made a mistake. And if you make this mistake, it's very possible that you can get the wrong answer and you'll get marked off points and all this sort of stuff. What I did wrong is that you actually need to subtract away all of f. So this is minus all of f right here. I only subtracted away the 3 as I have it written right here. I need to subtract away all of it. So I'm going to use parentheses here to denote that I need to subtract away that entire thing, not just the first term, not just that 3. So now it's fine. Now I have it written correctly. And now we can go about our merry way, I suppose. So let's go ahead and maybe simplify here. I'm going to write this as 3 plus, and I'll distribute this 2. So I'm going to do 2x plus 2h plus 5. And then I'm going to do minus 3 and then minus square root of 2x plus 5. So I distributed that 2, and I also distributed that negative sign there. And now we can see actually something good has happened here, right? With that 3 and that minus 3, these will perfectly cancel out. So maybe one more line, and then we're going to get to the big algebraic step here that we need to do in order to solve this limit. So 2x plus 2h plus 5, all under my square root, and then minus the square root of 2x plus 5, all divided by h. And whenever you have kind of these square roots, or in particular, any old square root there, plus or minus something, kind of you should be naturally thinking about, well, what would happen if we multiplied by a conjugate, right? So the claim is if we multiply by a conjugate here, this is how we can get these square roots to cancel and kind of make some good progress on this limit problem. So I'm going to go ahead and multiply by the conjugate here. Let me use some parentheses. So let's see, this is going to be the square root of 2x plus 2h plus 5 plus the square root of 2x plus 5. And of course we're going to do that both on the top and the bottom, right? So that way, fundamentally, we haven't really changed anything here. This is just a fancy multiplication by 1, and multiplying by 1 doesn't change anything. All right, so with that, let's go ahead and simplify, right? And if you go ahead and you FOIL this all out, you do the firsts, and you do your inners, and you do your outers, and you do your lasts, right? There's ends up being quite a lot of simplification. And what we end up with is basically, and this is this kind of product of conjugate binomials is what it was called. So it just says, right, if you have kind of this a minus b and a plus b, so there's our conjugates right there, and then this will end up being a squared, minus b squared. Or if you're going the other way, this is called the difference of squares rule. So this is what we're applying right here. So basically we just get to square the first term and square the second term, and that's why I'm going to get here 2x plus 2h plus 5 minus the second term squared. So that's going to be 2x plus 5. Now this is an important trick right here. It'll end up saving you a lot of time. So in the numerator here, or wherever you have these kind of conjugates, you want to expand this all the way out. But actually, when you're looking at the denominators and you're thinking, okay, should I go ahead and distribute that h? The answer is no. Kind of if you keep that h separate here, it'll end up being fewer steps. So that's kind of a nice tip there. Of course, you don't have to do it this way, but it's one thing that I found that makes it go a bit faster. And these are already pretty long problems, so it's nice to make them go a little bit faster whenever possible. All right, now we're ready for some more cancellation. Notice I have a 2x here, and then I'm subtracting away 2x. Likewise, I have 5 here, and I'm subtracting away a 5. So we can go ahead and cancel these out. 5 minus 5. And that's, again, very important that you have subtracting away all of this, right, using those parentheses. Otherwise, you would get the wrong answer, and that wouldn't be so great. So now we have the limit as h goes to 0. And let's see, what's left in my numerator? It looks like I just have 2h. Oops, that's one of the worst h's I've ever seen. There we go. And let's see, 2x plus 2h plus 5 plus square root of 2x plus 5. All right, and now because we didn't distribute that h there, you can see that actually we have an h on both top and bottom, and so those are going to perfectly cancel out. And remember, for these types of problems, we've been waiting for that h on the bottom to kind of cancel out because we want to plug in h equals 0, but we can't divide by 0. So we've just kind of been waiting, trying to get rid of that h in the denominator so that we could actually plug in 0, and now the time has finally come. So now, everywhere I see an h, I'm going to go ahead and plug in 0. So the numerator, of course, it just stays 2. And then in the denominator, okay, everywhere I see an h, I'm going to plug in 0. So I see an h here. So this is going to be, let's see, the square root of 2x plus, well, 2 times 0 would be 0. So that's just going to be plus an extra 5 there. And then we have another one, the square root of 2x plus 5. So our denominator has been simplified down as much as it possibly can be, getting rid of the h's and plugging in zeros instead. But actually now it looks like we kind of have these like terms, right? So these are exactly the same. So we could go ahead and combine like terms. It looks like we have 2 of them all together. So 2x plus 5, and we have 2 of those. And so actually there's going to be a little bit more cancellation here. And so my final answer, after the dust has settled and everything, is going to be 1 over the square root of 2x plus 5. And again, this right here is my f prime of x. Now, for my particular question, it actually didn't say find f prime of x or find the derivative function. It says find f prime of 2. So now that I have my derivative formula here, I can just plug in everywhere I see an x, I want 2. So if I want f prime of 2, well then, again, I just go back to my formula here, 1 over the square root of 2 times 2, that's going to be 4, plus 5. So this is going to be 1 over root 9, or that's the same thing as 1/3. So my final answer for that part is 1/3. What is the derivative of this function at 2? The answer is 1/3. Now this actually has a second part to it that we'll answer now. But everything's much faster. Now that we have this derivative formula, all of this stuff will be going fairly quickly. So what we want to do next is find the equation for the tangent line of f at x equals 2. And so for this, we need to remember the equation of a line. And this is kind of back in our algebra days. You may have seen it written a few different ways. This is the way that I remember that I like the most. So y minus the function's value is equal to m, so our slope, times x minus a. So this would be an equation of a line through a particular point. So at a, f of a, for instance. So in this case, we would like it through x equals 2. So this is going to be 2 right here. And then we want f of 2 then, in order to figure out what the height is. So we need to figure out what f of 2 is. And then, of course, because we want a tangent line, we already know that this bit, this m, the slope of the tangent line, well, that is the derivative. So we're actually fairly far in this. We just need to figure out what is the function's value at 2. So let's jump back up here. And okay, so we need f of 2. So I'm going back to my original function, my f function, and everywhere I see an x, I'm plugging in 2. So I have 3 plus the square root. Let's see, 2 times 2 would be 4, plus 5, so I get a square root of 9 there. So I get 3 plus the square root of 9, that's going to be 3 plus 3, so my final answer will be 6. I'm going to take that 6 and plug it in back down here, so everywhere I see f of 2, and so I get y minus 6 is going to be equal to 1/3 times x minus 2. So this would be the equation of the tangent line. Of course, we can rearrange this and solve it and make it y equals if you'd like and put it in its mx plus b form. But I find that this form right here is also very useful. The other thing we can do, and that you've been asked a couple of times, is to come up with a line perpendicular. So instead of a tangent line, find a line that's perpendicular for a particular function at a point. And so if you want to do that, right, we need to remember kind of how slopes, if you want perpendicular lines, right, so if this two lines here are perpendicular, the claim is their slopes are opposite reciprocals. So you may have seen, if this is m, then this would be negative 1 over m. And so it's the same thing here. If you wanted to come up with a perpendicular line, then instead of 1/3, well, we have to take the reciprocal of that, and we need to make it negative. So if I just write down, if this was an alternate question, so alternate, so if it wanted a perpendicular line, then I would write down y minus 6 is equal to negative 3 times x minus 2. So now it goes through that same point still, right? We want to still have it hit at x equals 2 and touch our function there. But in this case, because we want it perpendicular, I'm going to use negative 3 instead of 1/3. And just really quick, since we're not in a formal, exam or anything, it's nice to be able to double check our work and make sure that things are behaving like we expect. So I went ahead and I graphed this. So I have our function here, this 3 plus the square root of 2x plus 5. I went ahead and I said, well, we're interested at the point at 2. And so we can see here, we have our function, and then we have this line that seems to be just barely touching at the x value of 2, and that right there would be our tangent line. And that's going to be my y minus 6 equals 1/3 times x minus 2. And if you wanted to check the perpendicular line, so I'll do all of the same things here, but instead of 1/3, I'm going to put negative 3. And hopefully this looks like it should be perpendicular to our curve at this point. So yeah, that looks like our perpendicular line. So all seems to be behaving like we would expect. All right, with that, let's go ahead and start thinking about some of these derivative rules that we've learned. And I'm going to jump back here really quick and take a look at kind of all of these as a whole, and kind of talk about what is the roadmap, how are we going to tackle these types of problems. So let's figure out kind of what rules are going to be governing these things. For this first one, claim is we're going to need to use the quotient rule. So, okay, quotient. Oops. And you need to use the quotient rule whenever you see kind of the division of two different functions, right? Quotient is just one of those fancy words for division. So because we have a sine of x and then it's divided by 2x, that's when we need to use the quotient rule. For this next one here, the claim is we're going to need to use the product rule. And this is because, right, product is just a fancy word for multiplication, right? And we have two different functions, so 5x and tangent x plus cosecant x being multiplied together. So these are being multiplied. And you can see I tried to emphasize this. I even gave us this little dot here to symbolize, the multiplication. But sometimes, right, they don't even write that. And instead you might see 5x and then just in parentheses, tangent x plus cosecant x. And you still have to know that these two functions are being multiplied together, even though there's no multiplication symbol in between them. All right, so that's going to be the product rule. And then finally, this one right here is going to require the chain rule. And the chain rule, you use this whenever you have more complicated functions inside of other functions. So notice that this is not just sine of x, right? But this is sine of, and it's something more complicated inside of it here. And so whenever you have a more complicated function inside of another function, not just regular old x. Notice all the other ones before this, right? Sine of x, that was relatively nice. Tangent of x, okay. Cosecant of x, right? It was all just x's in these complicated functions. But when you have something more complicated, right, in this case we have the square root of 1 over x plus 3, that's when we need to use the chain rule. So that's going to be kind of our roadmap, what we're going to be doing when. Now let's go ahead and start solving some of these problems. So I'm going to go ahead and jump down to our first one here. Find the derivative of the following functions, and we're starting with our sine of x divided by 2x. So let's check here, since we need to use the quotient rule, let's see if the quotient rule is on our formula sheet. So quotient rule, that would probably be like under derivatives or something. So, okay, derivatives, and sadly it doesn't look like it, right? So the quotient rule and the product rule and the chain rule, these are things that we have to memorize, unfortunately. So, okay, for the quotient rule, This was whenever you have the derivative of kind of a function on top and a function on bottom, right? A quotient of functions. And it goes the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And there's what kind of relatively famous phrase here, right? It goes low d high minus high d low all over low squared. So this is for if you have a high function and a low function, and you want to take the derivative of this. So it goes what? Low d high minus high d low all over low squared. So, and this is kind of taking the places of our numerator and denominator here, our f's and our g's. So if you like this, again, the d would be for the derivative. So the derivative of the high, the derivative of the low. So the derivative of the high, that's my f prime. The derivative of the low, that's going to be my g prime here. But this is one way that you can memorize the quotient rule if you need. So for me, let's go ahead and we're going to take the derivative of this following the quotient rule. So we need, okay, first of all, the derivative of the top function. So the derivative of sine is going to be cosine times the bottom. So we don't take the derivative of it yet. We just leave that one alone for the time being. Minus the top function, f is sine here, times the derivative of the bottom. So now I'm looking at the bottom here and I need to take the derivative of 2x. Well, that's going to be 2. All divided by our low squared. So that's going to be 2x. Again, it's all being squared, so we need to use parentheses there. If you forget the parentheses, right, and you just write 2x squared, right, this is fundamentally different, right? This is a different answer than this right here, and so you need to make sure that you square the entire bottom there. And this is how I would leave my final answer, right? I wouldn't try to simplify it beyond this or anything like that. This is what I would highlight or box and call it a day sort of deal. So, all right, let's go ahead and move on for our second one. This one has even more trig in it. Again, we're going to be using a product rule because there's a product of two functions, or there's two functions being multiplied together. So let's go ahead and review. If you have the product of two functions and you want to take the derivative, we're going to do the derivative of the first times the second plus the first times the derivative of the second. So something like this. Kind of, there's still one derivative and it kind of takes turns, right? First it's with f, then it's with g, then you kind of treat them all equally. You add them all together. So, okay, we have one function. This is going to be my f function, and then my second function, this is going to be kind of my g function for this product rule, just like that. And since we want this thing's derivative, let's go ahead and write down here, well, it's going to be the derivative of the first function, the derivative of f, so the derivative of 5x is going to be 5. Then we leave the second function alone for the time being. So tangent of x plus cosecant of x plus, now we're moving on to the next one, right? We want just regular old f, that's going to be 5x times the derivative of g. So here's my g, my second bit there, and I need to take the derivative of this. And so remember in the video, I recommend that you memorize what is the derivative of tangent, so that way you're very quick with this. We can figure this one out using the quotient rule, right, but it would take a lot of time. So if you remember, the derivative of tangent is going to be secant squared. Plus, we also need to take the derivative of cosecant of x. And this is one that we don't require you to memorize, right? We're only having you memorize a couple of them there. This one's actually on the formula sheet. So if I go back, cosecant of x, if I want the derivative of this, this is going to be negative cosecant times cotangent. So negative cosecant times cotangent. So, okay, we're going to have negative cosecant times cotangent. And we can see that actually, as I have it written right here, again, I've made a mistake, right? We need to have f being multiplied by all of g prime. So I have my f, my 5x, and I need to multiply it by all of this. So it's important that you remember those parentheses. Otherwise, you'll certainly get some points wrong, on the exam, or, very possibly web work and whatnot as well. So, okay, this right here is my final answer. Again, I wouldn't spend a lot of time trying to simplify this. I would just personally box this and call it a day, right? And this is a 100% answer there. All right, so there is the product rule. The last one that we're going to go over today is going to be the chain rule. And this one actually, there are multiple things going on here. And with these more complicated problems, I'm going to show you kind of a nice way to break these things up. So let's review though, before we actually get into it, right? We need to use the chain rule because we have this more complicated function, this square root of 1 over x plus 3 inside of the sine function. So whenever you have functions inside of functions, this is when you need to use the chain rule. So the chain rule says if you want the derivative of something, you know, a function inside of another function, let's take the derivative of that. The way that you do this is by taking the derivative of the outside function. So kind of the outside function, my f, I'm going to take the derivative of that. For the time being, we'll leave the inside alone. Then we're going to go ahead and multiply by the derivative of the inside. And this is the important part too here. People sometimes forget this. So you have to make sure you remember to multiply by the derivative of the inside. So okay, let's go ahead and try to apply this to our particular situation here. So in this case, again, my outside function, the last function that's actually acting on this is the sine function. So it's the outermost. So okay, I want to take the derivative of the outside function. So the derivative of sine. Let me go ahead and write down. I'm about to actually take the derivative of stuff. So the derivative of sine is going to be cosine. And then notice that whatever's on the inside there, this g of x, it just stays alone, right? I mean, we're not going to do anything to it yet. So this is going to stay the square root of 1 over x plus 3. So we're not changing that yet. Then we need to come in and multiply by the derivative of the inside. So this is this multiply by g prime. So this inside function, we need to multiply by its derivative. So, okay, we're going to do the square root of 1 over x plus 3. And I'm just going to use this as a placeholder to say I need to take the derivative of this thing. So I'm using that little prime notation to say I have to take the derivative. This is a good way to earn some partial credit as well for any of the standard response questions. So you can see that I have it right up to so far, but this other derivative is even complicated on its own. So we need to spend a little bit of time trying to figure out what this thing is, and then we'll plug it back in. So let's do a little side problem here. I need to figure out now what is the derivative of the square root of 1 over x plus 3. And you may remember with a lot of these square root ones, right, you're going to end up using the power rule, but it requires a little bit of rewriting. So let me go ahead and I'm going to rewrite before I even take the derivative. So the derivative will come here in a second, but let me just go ahead and rewrite this. So the first thing is, right, the square root of 1 is just 1. So I could simplify that down. And then in the denominator, right, this doesn't simplify down at all. So this is still the square root of x plus 3. Again, with these square root problems, we remember probably that the square root is the same thing as being raised to the 1/2 power. So instead of the square root, I'm going to go ahead and put raised to the 1/2 power. And then finally, our last thing up for exponents here, that if you have something in the denominator, you're allowed to bring it up into the numerator, but it costs you a negative sign. So I'm going to go ahead and rewrite this one last time here as x plus 3 raised to the negative 1/2 power, and I'm bringing that up into the numerator. So again, this is all algebra, no calculus yet. I haven't taken the derivative. I'm just rewriting this function in a way that we can actually apply our derivative rules. Because now that we have this, we can go ahead and apply our derivative rules. And the derivatives for this would say, right, again, we have this outermost function as this power of negative 1/2. So we're using the power rule. This should come down, negative 1/2. Reduce our power by 1, so it's going to be negative 3/2. So that's the derivative of the outside function. We leave the inside alone, x plus 3. Then we go ahead and we multiply by the derivative of the inside. So the derivative of the inside, well, the inside was this x plus 3. That's just going to be 1. So you can see we actually have another smaller chain rule problem inside of our chain rule problem. So this simplifies down all the way to negative 1/2 x plus 3 raised to the negative 3/2, right? Because multiplying by 1 doesn't really change the result at all. So going back and actually solving our problem now, my final response, or my final answer here, cosine of the square root of 1 over x plus 3 times, and then we did a bunch of work on the side, right, to figure out what this thing's derivative was. And so after all the smoke cleared, we got negative 1/2 times x plus 3 raised to the negative 3/2. And that right there would be my final answer. This is what I would highlight or box. Again, don't spend any time simplifying that. That would be my final answer. All right, that's it for me this week. Again, make sure that you're starting to think about studying for the midterm. In fact, here at the very end, I'll go ahead and I'll bring up our web work. Where is it? Maybe over here. I thought I had this up. I was looking at some of these. And okay, so our web work, I wanted to bring up that there is this practice midterm exam, which I think is quite useful. In fact, our actual midterm exam may have some problems pulled directly from this practice midterm. So you can go ahead, you can take this multiple times. It actually gives you different constants and even different problems. It doesn't count for an actual grade. Oops. I forgot. I'm not actually, I need to enroll myself in there, but okay. So it doesn't count for an actual grade. Sorry, I was going to show it to you, but apparently I can't get into it. But again, I think it's very useful because those problems, you know, could show up on the actual midterm exam. So please make sure that you're taking a look at that. That's going to be some great studying resource. All right. Good luck on our quiz tonight. I'll see you guys out there.